Hello students, my name is Pankaj Pathania and today I will discuss the most important topic in the point of view of engineering, that is helium neon laser, and it is first working laser and which is developed by Ali Jeevan in 1961 in Well Laboratories. This is the most used laser, and it is basically used in the our shopping complex. There is data reader is there, that is called the barcode reader. So helium neon laser, and first of all we will just remind that what is laser. Laser is light amplification by stimulated emission by radiation. So basically laser is nothing, it is the coherent source of light, it is the coherent beam, that is a, you can say that is a coherent source of light, and it have various applications, and after that we will discuss the application also. So first of all we know what is the principle of the discuss stimulated emission. What is the stimulated emission? When the light is incident on the material, then the atom is, when the light is excited, then the atom is excited from the ground state to the excited state. That is called the absorption, stimulated absorption. Understand? When they come from the higher state to lower state, then it will be in the form of, when it is come in the form of spontaneous emissions, that is the principle of LED. And third is, the main is stimulated emissions. Stimulated emissions means, that is the stimulated emissions. Stimulated emissions means when the photon is coming and at metastable, there is another state that is minus 10 k minus 3 seconds, that is the metastable state, and the normal excited state is 10 k minus 8 seconds. So atom is goes to the excited state and it is come back to the metastable states, and they stay there for the long time, 10 k minus 3 seconds. When they stay in this form, then this photon have get enough time to interact with this atom and just perturbed this atom. It is not change the characteristics. So when the external photon perturb or disturb the atoms, then it come back to the ground state and emitting the same photon, same energy photon. That is the one. What here we have to get the two photons. Understand? And that means we have produced one photon to two photon, and by mirror M1 and M2, or the by using resonator, we can amplify from the 1 to 1 2 and 1 2 to 4 4 to 8 8 to 16. So there are the amplification of the photon. But why this happen? Because in case of helium neon laser, there will be the metastable state. So that's why not every material fabricate the laser or design a laser. Only those materials, those solid produce or gases produce a laser which have a metastable state. Metastable state characteristics, that is the lifetime is 10 k minus 3 seconds for the atom. Understand? So this is the basic principle. To achieve the stimulated emissions, we need the three basic parameters, or we can say that the components. And there are three components. One is active medium, second is basically pumping mechanism, and third is resonator. So here, what is the active medium? Active medium is, what is the quality of this active medium? First of we will discuss, because to achieve the stimulated emission, active medium have the following properties. First is it has metastable state. Which has lifetime of 10⁻³ seconds. Through this metastable state, we achieve the population inversion. Understand? And when we achieve the population inversion, then we can able to create the laser. So here in case of helium neon laser, active medium is helium neon. That is the gas laser. It is in the form of gas, and it is the ratio of 10:1. 10 atom of helium and the 1 atom is neon. And the second most important component of the laser is basically pumping. And here in case of helium neon laser, we use electric discharge method. In another laser like ruby laser, we use light. Understand? But here in case of helium neon laser, we use electric discharge method. And third is resonator cavity. It is basically useful for the amplification of the light photon. So resonator, what is the resonator is M1, that is a mirror that is fully silver, and M2, here is the M1 is the medium that is mirror fully silver, and M2 is the mirror which has half silver. Understand? So both component, active medium helium neon inside this chamber, that is the helium neon is a gas is there. Understand? That is the ratio of 10:1. And the other component is pumping mechanism, that is the power supply that will perform the electric discharge mechanism. Third one is the resonator, that is M1 is the mirror that is fully silver, and M2 is the half silver. So distance between the two mirror is half integral of lambda by 2. Lambda is the wavelength of light. Understand? Now this is the construction. M1, we again repeat, M1 and M2 is the two mirror. M1 is fully silver, M2 is the half silver. And here is the power supply. We have given the for the electric discharge mechanism, and that is the laser. And here is the photon. So through these mirror M1 and M2, these photons will be amplified, and when there is the laser beam is formed, then the laser will be come out from the this M2 side. So here we will be discuss about the energy level of helium neon laser. So helium neon laser is 4-level laser. Is 4-level laser. Why? Because in this we can say that the energy levels of helium and neon, this side, because we are using the combination of helium and neon at the ratio of 10 to 1. Understand? So the energy states of helium, there is a F0 is a ground state, and the other state like F3 and F5. The energy of these states are 20.61 electron volt approximate and 19.9 electron volt of the F3 states. These energies are same to the energy level of metastable state of E3 and E5. Understand? So these are the 4 level. That is the, here we can say that this, here we can make a correction. There is a another state is there, that is a E0. If we have taken E0, and this is E1. There is a 1, 2, 3, 4, 5, 5, 6. Means we have 4 level. 1, that is 2, and this is 3, and this is 4. So that's why it is called the 4-level laser. Now the question is why we are using helium? Because the helium atom are lighter as compared to the neon, and through this helium atom we can excite the neon state up to the metastable state, and through this we have required less power for pumping. Understand? Now the question is, what happens when we have applied the power of 5 to 10 watt, and due to electric discharge method, the electron will be collide to the helium and neon, and the helium and neon atom will be excited to the excited states, higher states. Understand? Because helium is more as compared to the neon, so the probability of collision between electron and the helium is more. So when the helium is excited through their states, higher states, then helium transfer their energy to the neon, and the neon is excited to the metastable state E5 and E3. E5 and E3 is the metastable state. So the energy of the helium will be transferred by the collision. So excited helium atom will be collide with the neon, and the neon atom will be excited to the metastable states. And at the metastable state, the lifetime of the stay of these atoms is 10⁻³ seconds, and when they come back to the low state, then they release the energy through the form of laser. Understand? So here, but what will happen when electron collide, when electron collide with helium atom, helium neon gas atom, then what happen? Helium and neon will be excited to the higher states. And why we are using helium neon combination? Because the higher energy state of helium, the energy of higher state helium is same as the metastable state of the neon. So all the lasing phenomenon occur in the neon. The helium will, what is the function of helium? Helium will provide the energy to the neon to get the excited, and it is easy to excite the helium as compared to neon, because helium has the less mass as compared to the neon. So it can also reduce the cost, because it needs less power to excite the helium as compared to the neon. Understand? So Now the transition probability, what will happen when the helium transfer the energy to the neon atom, and it will be go for the higher state, and at the metastable state there will be three process. One is E5 to E4. Some of the neon atom lose their energy and come to the E4 state, energy state, and it will be emit the photon of 3.3 micrometer. It is basically in the range of IR. And from E5 to E2, they emit the laser of wavelength 6.632.8 nanometer. That is the red light. And another is emission will be occurred through the E3 to E2, which emit the photon of 1.15 micro. Understand? So these are the laser phenomenon, but the most important for us is this visible range laser. When end up from the E2 to E1, then again from the E2 to E1, there will be the emission through, there is a lose the energy, neon atom lose the energy through the spontaneous emission. And from E1 to E0 ground state, the energy lose by neon through the collision with wall of tube. Again, when the neon come back to this ground state, helium will again transfer their energy to the neon, and again the neon will be come to the metastable state, and again the lasing action should be occur. Understand? So here is the 4 level. Why? Because E5 is another state, E5, E2, E1 and E0. If I am taking the metastable state E5, then it is 4 level, 1, 2, 3 and 4. So that's why it is called the 4 level laser. Understand? So question is always come, what is 4 level laser? Then you should try for the helium neon laser, because it is a 4 level laser, and the question is again asked in the form of what is the gas laser. So helium neon is also a gas laser. Understand? And after this, when the photon of 632.8 nanometer is generated, it passed through the helium neon gas. Understand? And it is partially reflected by the mirror M2 and come back to and just excite another neon atom and emitting the same energy of photon as the 632.8 nanometer. So when the beam of sufficient energy or the intensity of the beam of this laser is generated, then it is come to this partially mirror M2. So we can get the laser of power of 1 to 50 milliwatt in case of helium neon laser. Now the applications of these application of helium neon laser, one is barcode reader. We occasionally find in our mall when we are in the shopping complex, there is a barcode reader, and that is basically helium neon laser, and it is also used for the holography. For holography to generate the 3D image. Understand? So, and third is for the basically scientific and characterization techniques. It is mostly used for the scientific in the laboratory for various experiment purpose, varies for the characterization methods or the techniques. So these are the basic applications of the helium neon laser. And the other question will become, why helium neon laser is, which is gas laser, is superior than the ruby laser, that is the solid state laser. Why? The next is advantages of helium neon laser than ruby laser. Ruby laser is basically the solid state laser. We are already discussed in the previous lectures. So ruby laser, first is basically pulse. In case of helium neon, and this is basically ruby laser. Understand? Pulse, it is as a continuous pulse. Helium neon laser give the continuous pulse and ruby laser in the pulse form. Understand? Second is cooling method. Helium neon not required any cooling mechanism. That's why it is very, cost is very less of these helium neon laser, and for the ruby it is required. Its cooling mechanism in case of ruby laser is required, and imperfection imperfections in case of gas laser, the imperfection is negligible, and in case of ruby laser, because it is solid state laser, more losses due to atomic imperfection or defect. So these are the basic advantages of helium neon as compared to the ruby laser. So this is the basis of helium neon laser, and it is very important. So thank you very much.